Hello, this is the genuinely approachable Sudoku for the 12th of February 2024. It is Later Than You Think by Bill Murphy, featuring, I guess, little killers as well as quads. So let's look at the rules. Normal Sudoku rules apply. Place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits along indicated diagonals must sum to a given total. So for example, those digits would have to sum to 9, those digits sum to 21, and so on. Digits in circles must appear in the surrounding 4 cells. So this circle here has digits 1 to 3. So the 1 and the 3, well, there must be a 1 and a 3 in these 4 cells. And the other 2 numbers could be anything. So you could even have duplicates here. This is technically fine, as long as at least one 1 and at least one 3. Yeah, so those are the rules. With that, let us begin solving. So yeah, we could probably do something with the 8 and the 21 here because they're the biggest numbers. This 6 and the 7 cannot be in the path of the 8. And the reason why is because if you had 6 or 7 here, the remaining digits have to add to 1 or 2. And that's just not possible in 2 cells that are different because they're in the same box. So if you imagine this was a 6, those digits cannot sum to 2 without them both being 1. So you cannot have 6 and similarly you can't have a 7 in the path of the 8, and therefore 6 and 7 must be on the opposite side of the circle. Opposite side. And we can, well, firstly, this 9 here means those digits sum to 9, so that digit has to be 2 or 3. Another thing we can do is we can also prove that 1 and 2 cannot be in those cells for the same reason. If you had a 1 or a 2 here, the remaining digits have to add to 20 or 19, which isn't possible in 2 digits at all. So those cannot have 1 or 2 in them, those must have 1 or 2 in them. And in fact, this 11 means that that digit can't be a 1, because that digit can't be 10. So that has to be 2, which must be next to 9. Oh, not next to 9, but you know, must be with 9 to form 11. That's 1. So those digits have to be, yeah, they have to be the next highest numbers because they can't have 9 in them anymore. So those digits would be, the maximum you can make them is 8, 7, and 6, which do sum to 21. And so they have to be 8, 7, and 6. I guess we also know that 9 is in this quad somewhere, but this 9 sees those cells, so 9 has to be there. 3 and 4 in this quad now come in those cells, so they have to be here, forming a 3-4 pair. Right, so I guess where does 4 go in this quad? There is a 4 in one of those cells which sees that. The 4 here would see those cells, so 4 must be there. Yeah. And then so those digits have to be 3, 4, 5. That digit is not 4. Cool. Yeah. Not sure what else we can do here. Oh, we can do the same here as well then. Probably here as well, I think. Yeah, those digits sum to 22, but if you had 3 or 4 in this line, then the remaining digits have to add to 19 or 18, which isn't possible with different digits. Yeah, 19 just isn't possible, and 18 requires 2 9s, which also isn't possible because they're in the same box. So those digits can't have 3 or 4 in them, those digits must have 3 or 4 in them. Those digits have to sum to 11, so that's 7 or 8. And then those digits, well, 22 must have a 9 in them, because we said without a 9, the maximum you could have is 21. So 22 must have a 9 in it somewhere, and because of those 9s here, the 9 has to be in that cell. And then those digits have to sum to 22 minus 9 is 13, right? They have to sum to 13, but they could be, you know, 5, 8, or 6, 7. I don't think we would know. So that's great. Alright, let's keep moving on. This is the exact same idea as, I think, this one, yeah, where 8 and 9 definitely can't be in those cells, because you can't have 8 here. If that cell was 8 or 9, then the remaining 2 cells must be adding to 1 or 0, which doesn't work at all. So 8 and 9 can't be in those cells. 8 and 9 have to be here. And similarly, this cell can't be 9 because that cell can't be 0. So this must be 8 accompanied by 1. That digit has to be 9. Yes, and for the same idea here is that because those digits do not contain 1, the minimum they can be are 2, 3, and 4, which do add up to 9, so they have to be 2, 3, and 4. Therefore 6 and 7 must be in those cells. So 6 in this quad because of 6, 7 here. Can't be there. Can't be there. So 6 goes there. And also those cells are 5, 6, 7. Sorry. Which means, well, this 1 over here means that that digit has to be 1. And we do know that 8 must have a 1 in them. Because the minimum, again, without 1 would be 9. And those digits can't be 1, so 1 goes here. Cool. And those digits then have to sum to 7, which could still be 2, 5, or 3, 4. I don't know if we figured that out yet. Cool. Okay. Very symmetrical so far, which is probably a good thing, although it's a bit harder to solve at this point. I think we have to resort to Sudoku now? Maybe. I guess because now those cells are 3, 3 is in one of those cells. What does that mean? I mean, like here 7 is also in one of those cells. That doesn't say anything, does it? I don't know. Alright, so yeah, let's look at where does 9 go in this box, I guess. Because this 9 sees those cells, they can't be 9. You can't have 9 being those cells because those digits have to add up to 8. So those digits are less than 8, meaning that cell has to be where 9 goes. Can probably do the same thing with 1 here. 1 can't be in those cells, and because those digits have to add to 13, 1 cannot be in those cells either. So 1 has to go there. Same for 2 actually, because those cells sum to 13, they can't have 2 in them. So 2 is in one of those cells. What does that mean? Don't know. Yeah. Which ones have we figured out? Yeah, I think this quad and this quad is the only one we haven't used fully. We still have stuff to deduce from them. The fact that 3 is in one of those cells, yeah. Are all the clues? No, all the clues are not technically done yet. Oh, this 2 actually sees that cell. Why didn't I see that? So that's 3. Meaning those cells, which add up to 7, can't be... they can't be 3, 4, or 1, 6. They must be 2, 5. Wait, which means 8 would see that cell. Yeah, that's 7. Which means those can't be 4, 9, or 6, 7. They have to be 5, 8. Oh, so those digits are 2 and 6 then. Which means those 2 digits are 4 and 8. 4 and 8. Awesome. So that digit can't be 6. That digit can't be 4. Anything else we can do? Yeah, this 3 resolves this 3, 4 pair. 4, 3. 4 can't be there, so 4 in this box has to be here, which resolves this 3, 4 pair. That doesn't resolve anything. This 3 actually resolves this 3, 5 pair as well. So there you go. Could probably do the same on the other side, where this 7, yep, resolves the 6, 7 pair. This can't be 6 or 7, so that's 5. That's 7, that is 6 here. Which resolves this 6, 7 pair. This digit now can't be 7, and that digit now can't be 6, which means that in this box 6 must be there, which means 7 has to be here. Yeah, 3 now can't be there, which means 3 goes there. This digit can't be 4, so 4 has to go here. Cool. 6 here resolves this 2, 6 pair. And I think something here resolves that. Yeah, 4 here resolves this 4, 8 pair. 8, 4. And then those digits form a triple of some sort. I don't... Sorry, it's taking me a while to figure. It's 2, 3, and 5. Well, 3 come in those cells, so 3 must go there. 2 goes there. And we can do the same here, where 8 come in those cells, so 8 must go there. 7 must go there. Whoa. Whoa, okay, I broke something. Wait a minute, I broke something. I broke something. Yeah, I definitely did. Wait, hold on a second here. This works though. Which means I definitely did something wrong there. Oh, this digit is not 8, it's 7. Why did I make it an 8? I think I misclicked. It's 7. Which does work, because that means that this digit is 7, that digit is 8. Alright. So resolving this 5, 8 pair. Alright, and it's just regular Sudoku from here. I'm so sorry for the confusion. This is 5, 8. That's 1, 7, which we can resolve. 7, what am I doing? 1 does go there. That digit is a 6. And then those digits are 2 and 3, which is also resolvable. Can probably do the same here. Is this another one of those X windmill ones? I think it is. That's 2 and 5, which we can resolve. 5, 2. Those digits are 4, 6. No. 4, 9. Whoops. 4, 9. There you go. And then those digits are 7 and 8, which we can resolve, which also resolves this 5, 8 pair down there. We can do the exact same thing here, where those digits are 6 and 8. Yep, resolvable. Those digits are 2 and 7, also resolvable. And then those digits are 5, well, 1, 5, 1, 5, and 9. We know 5 is one of those cells, and this 5 actually sees that cell, so 5 has to be here. Cool, and then I guess we can also say, yeah, 5 has to be one of those cells, 5 can't be there, so 5 goes there. Which is sort of very X windmill-like. Interesting. Those digits are 2 and 4. Those digits are 3 and 8. And then those digits are 1 and 9 again. Awesome. We can keep going here. 7, 8, I think? Well, 7, 8, 9. Yeah. This can be 7 or 8, so that's 9. This can be 7, so that's 8, that's 7. This 9 resolves all of these pairs down here. Those digits are 1, 2, and 3. This can be 2, 3, so that's 1. This can be 3, that's 2, then that's 3. Last 3 digits are 4, 5, and 6. That's 4, that's 5, that is 6. Solving the puzzle in 11 minutes and 37 seconds. Nice. Well, I hope you enjoyed that puzzle. I'll see you next time. Bye bye.